All right, so next thing we're going to do is writing equations of lines. Um, Yesterday we talked about slope. That was a review from Algebra 1 and even middle school and everything else. Today we're going to review some more stuff from Algebra 1, writing equations of lines. Now, there's two major forms that we're going to talk about in this chapter. The first one is called point-slope form. Oops, I put in an extra hyphen. But I'll call that PSF. Point-slope form is PSF. Now, for those of you who forgot what point-slope form is, here it is. Y minus y sub 1 equals m times the quantity of x minus x sub 1. Notice the subscript. Those aren't exponents or anything. It's below. Now, m, of course, is the slope, just like we talked about yesterday. And the point x sub 1 comma y sub 1 is any point on the line. Any point on the line. All right, so that's the first big one, point-slope form. The other big one is slope-intercept form. Now, slope-intercept form, or oops, I forgot what form, or SIF, as I'll call it a lot, is the one that everybody knows and loves. Stingle, what's slope-intercept form? You probably said it right. Y equals mx plus b. Good. So, once again, m, of course, is the slope. And b is the y-intercept. Sorry for my sniffliness. Y-intercept. I usually like to write it as 0, comma b. Now, these are the two major forms I'm going to ask you to play with. What's great about point-slope form is, like I said, you can use any point and you can put it in point-slope form. Then, if you distribute the m and then get y by itself, it mathematically gets put into slope-intercept form. So what I like to do is start in point-slope form, no matter what form it's in, pretty much. And if they want slope-intercept form, I'll take it the next step. All right, let's do our first example. Our first example is, I'm going to give you a point and a slope. I want you to write the equation. Write the equation of a line through, that's right, I misspelled through, what? Through the point -5, 7, with the slope of -2. All right, so first thing I want you to do, I want you to start off in point-slope form. Who's got point-slope form for me? Matt H. Oh, he was about to say it, and then he put his hand down and said, never mind. So, you ready, Matt? Go for it. I don't know. Did he say it right? Here's what it should be. Should be y minus. No, you take the y coordinate. Y minus y sub 1. Think of this is x sub 1. This is y sub 1. And of course, that's m. So y minus 7 equals m, -2 times the quantity of x minus x sub 1. Now, minus -5, that's the same thing as plus 5. That's point-slope form. Now, here's what's magical about this. If all they want is point-slope form, or if they write the equation, boom, you're done. That's it. All right? But for the sake of our notes, we're going to do it in both forms. So, here's point-slope form. We're all set there. We're going to take it to the next level. So, put it in slope-intercept form. You're going to distribute. So, you got y minus 7 equals -2x minus 10. Y minus 7 equals -2x minus 10. Then get y by itself. Y equals -2x add 7 to the side, you get minus 3. That's our slope-intercept form. Y equals mx plus b. So our slope is negative 2, just like we said. And our y-intercept is 0.0, negative 3. All right, so here's what's up. If I give you a point and a slope, you should be able to give me both forms, whichever form I ask for. All right, let's do the next example. Next example, what if I give you 2 points? What if I give you the point 1, negative 5, and the point 2, negative 7? Now, no matter what form I start in, both point-slope form and slope-intercept form both require what? Matt K probably said it. Or he's got his hand raised. Somebody else shouted it. But yes, we need slope. We need slope for each one. Now, here's the thing that I like to do, though, before I even get started. I like to make a quick little sketch. Nothing fancy. Got the point 1, negative 5. And I got the point 2, negative 7. There's like a rough sketch of what my graph is going to look like. Now, what kind of slope do I expect to have? I expect to have negative slope. And my y-intercept's even. Now, I didn't draw this to scale or anything, but I'll bet you my y-intercept's going to be negative if I have to find slope-intercept form. Which we do, because we're just taking notes and just learn this. So, no matter what, the first thing we need is slope. So let's start with slope. Slope here is going to be negative 5 plus 7 over 1 minus 2, which is 2 divided by negative 1. Our slope is negative 2, just like we said, it's negative, yeah? All right, so that brings us to point-slope form. Now, I got a slope, but which point do I have to use? Actually, it turns out it doesn't matter which point you use. All right, so we're gonna do one with the first point. So point-slope form is gonna be y plus 5 equals negative 2 times the quantity x minus 1. There's point-slope form. If that's all they want, that's all you got to do. You're all done. Now, go ahead and put it in slope-intercept form now, though. So distribute. Y plus 5 equals negative 2x plus 2. Get y by itself. Y equals negative 2x minus 3. What? Look at that. It's the same equation as before. How about that? Who knew? Didn't even try for that. Anyways, well, what is Mr. Smith? What if I use this point? I bet it would come out completely different. Well, maybe. Let's check it out. So, if I use this point, it would be y plus 7 equals negative 2 times the quantity of x minus 2. Distribute. We get y plus 7 equals negative 2x plus 4. Subtract 7 from both sides, and you get y equals negative 2x minus 3. Look at that. Doesn't matter which point you use, as long as you set it up correctly and solve for y correctly, you'll always get the same slope-intercept form. All right, so I've done a couple now. I'm going to give you 2 more examples. I want you to talk to your peeps, and I want both forms for these two. If I give you the point 6, negative 4, and the point 2, 8, find the equation of that line. And our next example is going to be 1, 1 and 7, 4. Hey guys, just because it ain't pretty doesn't mean it's not right. All right, so go ahead and press pause, and you and your peeps hook up these 2 examples. Ready, go. All right, so hopefully on both of these, start off with slope. Slope is negative 4 minus 8 over 6 minus 2, which is negative 12 over 4. Number 1, your slope should have been negative 3. So your point slope form. Uh-oh. I need some more room. Hopefully your point slope form was y plus 4 equals negative 3 times the quantity of x minus 6. Now, you could have used this. In fact, if I was doing this, I probably wouldn't have chosen this first point. I would have went with this one. Why would I have chose this second point rather than this first point? It's kind of a weird question for some. Matt put his hand up and then put it down. Sydney! Why am I choosing this one instead of this point? If I'd imagine, Sydney probably said it right. Right, because this is negative, right? I don't like, if we're going to make a mistake, it's probably going to be with the sign. So I'd go with this because there's no negatives. So y minus 8 equals negative 3 times the quantity of x minus 2. All right, I don't got to worry about plus or any nonsense like that. Anyways, do you need both of these? No. One of these for point slope forms will suffice. But for point slope intercept form, y equals negative 3x plus 18, you should have got y equals negative 3x plus 14 for your slope intercept form on this first one. The second one. Oh yeah, that last one, I didn't do my little trick, right? 1, 1, 7, 4. I should get a positive slope with a relatively low y-intercept, probably. But, no matter what, it starts with slope. So, I'm going to go 4 minus 1 divided by 7 minus 1. 3 divided by 6, which is 1/2. Positive slope, that looks about right. So, my point slope form, it's going to be y minus 1. You betcha I chose that one. Equals 1/2 x minus 1. Or, of course, y minus 4 equals 1/2 x minus 7. Either one of those will work. Then, slope intercept form, y minus 1 equals 1/2 x minus 1/2. Add 1 to both sides. And get y equals 1/2 x plus 1. Alright, so hopefully y'all got those for those two examples. All of these equations, or for point slope form and slope intercept form, we've been talking about non-horizontal or non-vertical lines. But what if we do have the equation of a non-vertical or non-horizontal line? Or excuse me, a vertical or a horizontal line. I'm going to tell you a couple words. It sounds like a Harry Potter spell. It's called Hoi V-U-X. Hoivox. I don't know. To me, it sounds like something Harry would say when he was this little goofy one. Anywho, what's happening here? H. H stands for horizontal. Horizontal line. Horizontal line looks like this. As we talked about yesterday, what is the slope of a horizontal line? It is 0. This actually stands for 0. The O is 0. The slope of a horizontal line is 0. And the equation of any horizontal line is y equals some number. Okay? So, hoi, it's not today, for those of you in Spanish 1. Horizontal has a slope of 0, and the equations are always y is equal to a number. Then we've got vox. V, of course, is vertical. I should spell it right. Vertical. And this is a U. I know my U's are terrible. Yes, that's a U. U is talking about the slope. The slope of a vertical line. Remember, a vertical line is like this. The slope is undefined. Undefined. The slope is undefined. And the equation of any vertical line is x equals some number. All right, so this should be a review of graphing. That's the nuts and bolts. Go ahead and bust out your homework guide, and your homework is in the book tonight.